big applause for Philipp and give him a chance to tell you something about Kubernetes operators.
Hi everyone, thank you. So this will be a bit like more the story starting from containers to going all the way up to operators, but a bit like best practices. How do you build a container for a data store as well? So all I'm telling you today is pretty much from the perspective of a data store. It might be very different for for stateful stuff, but we'll dive into that. So I work for Elastic. My official title is developer advocate. So most of the time I travel around. Probably not so much in the future anymore, but we'll see about that. But I still made it here. I'm based in Vienna in general, so everything worked out for now. If you've never seen our stack, this is what we do. I will mostly focus on Elasticsearch itself, where you probably store some log data, full text search, or other data. That's what we do and where kind of this experience is coming from. So I guess everybody's using containers. This is like a stupid question at this audience. Who is using containers in production? I think that's still pretty much everybody, right? Mostly. Who is using stateful containers? Okay, that's far fewer. Is anybody using our containers, like the ones that we built? Okay, a couple. If you have good stuff to say it now. The bad stuff you can tell me in private afterwards. But we are interested in feedback. So I want to quickly take a look at how did we build our images and what are kind of like the principles of what we do in images. We'll probably skip quickly over Docker Compose and then mostly focus on Helm charts and Kubernetes operators. So starting with Docker, especially for data stores, what many of the containers that you're using are in size are probably something like this, where you have something where you are more like on the, I don't know, shark or whale size containers. If that is a problem, we can discuss afterwards. Internally, we have this very nice saying that Docker is the most heavily funded college project, especially when, like 2 or 3 years ago, when stuff was breaking all over the place and things were not working out as expected. That's the colleagues who started building our images were always referring to that. And even if you hate on Docker, probably you don't since you're here, but even if you do, it's pretty much the new zip format. So in the past, you used to get your software as a zip download. Nowadays, probably you consume it as a Docker container. So there is no way around that. Even if you don't like it, you probably need to provide those Docker images. For us, it's just one of many formats. It doesn't really matter if it's a container. Some vendors are very strong on the opinions and say like, hey, you should run this as a container. And we were always like, run it any way you want and think that is right for you. It's just one of the many ways to run software nowadays. Obviously, it's not without issues. So one of the things that I see more or less frequently that people want to do something like this, don't want to ask like who is doing that. You can also confess in private afterwards. And what used to be the snake, you can just replace the snake with a whale. And this is what many people are doing nowadays. So basically, inside your Docker containers, you run everything as root and you don't care about file permissions, right? And maybe you wouldn't believe it, but we get GitHub issues every now and then where somebody says like, we don't care about permissions, we just want to run everything as root in a container. Why can I not run your process as root? And we're like, this is a totally wrong approach, you shouldn't do that. But people sometimes insist on doing that. So for us, for example, we require that we have an Elasticsearch user and that we have a specific user ID and group ID. And if you have any files that you're writing, those need to have those permissions as well. And you cannot just use any random permissions on those. It needs to have the right user to work. And then every now and then somebody opens up an issue and you get something like this, where people say like, I prefer simplifier and forget containers. And what I always imagine what people want to do with their data then looks something like this. And this is fine if you have some stateless stuff, but as soon as you have data and maybe data in production, this is not what you want to do. So the way we build our images or think about our images is that there will be data in them and the data will be for production sooner or later. And if we don't make the right choices up front, you will suffer afterwards and probably complain on Twitter about us. And we don't want that, so we kind of want to enforce best practices up front. Something we see every now and then that people want to do some host mutation, like I think Docker Inc. built some Elasticsearch containers before we did, and they would just mutate the permissions on the bind-mounted directory on the host, which we think is a bad practice and we don't do, so you need to set up the right permissions if the container doesn't create the bind-mounted volume itself. Which leads us back to this one when everybody says like Docker is super simple and it just does everything automatically for you. If you know Linux and know how file permissions work, then yes. If you don't, you will run into things that you have never seen before and don't really care about. So yeah, if you don't know about file permissions, you will probably run into those at some point. The other thing that we see very frequently is latest. Who is using latest for external dependencies? Nobody. Okay, very good. Great audience. The problem there is that latest is kind of like promoted by Docker Hub. So if you go, for example, to our images, to the Elasticsearch image, and the recommended command that they have here is docker pull Elasticsearch, which implicitly uses latest. Does anybody know what will happen when I copy that command and run it? It will fail, because we don't have latest, because we think latest is a very bad idea. Why is latest such a bad idea, especially with a data store? Let's assume you today start the cluster with 3 nodes and you use latest, and then in half a year or a year you add 2 more nodes because you need more capacity, and you use latest again. Probably you get a new major version, maybe you break everything, and then you will be very angry with us. And we kind of want to avoid that. That's why we don't have latest. And the problem is, on Docker Hub, there is no way to add a version number here. Like what we would love to have is that this command here has the current latest version in it, and then you could just copy that. But that's not possible, and because of that, every now and then somebody will open a GitHub issue and say like, your images are broken because when I run this command from Docker Hub, nothing works. And we're like, no, this is a feature. And then everybody's, yeah, it's a feature. So yeah, we don't have latest. Sometimes people think they're like, oh, we'll do this in a smarter way, because you said like it will break on a major version. What if we pin the major version, and then I don't care about the minor version, or maybe the patch level version? Do we support something like this major version or this minor version, and you just get the latest version in that? No, we don't. Because the way that the data is internally structured, if you write some data, let's say with version 7.5 and you have a 7.3 node, there is a chance that the data could not be moved from a newer node to an older node, and then you might create imbalanced clusters, and it might lead to very weird failure scenarios that nobody wants. So we will always force you to pick up that version number up front. It's a little more pain now, but it will not break in an unexpected way later on. That's why we are pretty strict on that. The next thing that we see quite frequently, that what people want to do is some runtime mutation, that basically you mount some shell script and then you run something when you start the container. Or that you can provide an environment variable with which packages to install. Or we get feature requests for all of those. Which, again, we think is a very bad idea, especially something like this, like installing some plugins or so. Like, it might work on 2 nodes, and the 3rd node, like the internet connection is not working, or for some reason you don't get the plugin, and suddenly you have different images with different plugins, and then you might screw up your data in an unexpected way again. And this is just the wrong approach if you use containers. Build your images statically and then push them. Like whatever you do, just create one Docker file, push that image, and reuse it everywhere. Don't do that weird runtime mutation. Where do you put your certificates or key stores? Do you also build them into the image? Ideally not, because they probably have a different life cycle. Because when your TLS certificate ends and you need to rotate your TLS certificate, maybe you don't want to upgrade your Elasticsearch version. And then you can just keep the base image, but you just need to rotate those certificates or key stores. So unlike plugins, which should be kind of like burned into the image, those you would kind of bind mount. Like this is just a simple example where I create the key store, and then I could bind mount that key store, for example, in Docker Compose or whatever simple stuff you might be using. You could just bind the key store, and then you could reference your TLS certificate or your key stores or whatever from there, because they have a different life cycle than your image. So build a static image, but what has a different life cycle should still stay out of that. Base images are a tricky one. Who has very strong opinions about base images? 1, 2, okay. You will probably disagree with that, but all our base images are CentOS 7 nowadays. We started for Elasticsearch, we started with Alpine, but ran into too many bugs, which were not fun. So we moved over to CentOS. Then people ask, like, why CentOS? Because our largest user and customer base is in the US, and they like something Red Hat based. And that was kind of like the path of the least resistance. That's why we went with that. What is kind of the current pain point there is that many people use some security scanners and scan your images. And even though something is totally not exploitable, the security scanner will say, like, there are 20 security issues in this. And I think we have people working almost full time now answering automated scanner reports for companies being concerned. So we'll probably have to skip out to a smaller base image for that. What is nice about that, all our images have one base layer. We can just share that. The setup is the same. And the other thing is, since we want the JVM, not just the JRE, we want the actual JVM, our images won't be very small anyway. And the other thing is, with Alpine, MuCL is nice and fancy and whatever, but glibc might be old and ugly, but it's very battle tested. Like, we ran into way more problems with MuCL than with glibc. The downside is obviously our image size, which is on the large side. Are you very concerned with that? Yes, maybe. We're not so concerned with that because since this is a stateful image, you won't be deploying that 20 times a day. We don't release that often, and you don't make changes that often to that. And in comparison to the data that you keep in the image, probably the image size is still small. You keep, I don't know, a terabyte of data of data on your data store. If you care about 100 or 200 megabytes of the base image, probably doesn't make that much difference. If you have a stateless service that you deploy many times, this might be different. But for a data store, we are a bit less concerned with the size. But that's a discussion point we can have afterwards. Sometimes people ask for Windows-based images. Is anybody providing Windows-based images for their services? No? We don't have much Windows expertise in the team, that's why we try to avoid this topic. We really don't want to go there. Maybe you can switch, or I think if you are running on Windows, a recent Windows Server version, and you have a Windows-based image, you can skip this small Hyper-V layer, like this virtualization in between. That's why sometimes people really want Windows-based images, but we don't want to build them. So, yeah. Okay, Docker Compose. I guess everybody is using Docker Compose just for demos and quick setups locally, right? Not production. Is anybody using that for production? Okay, a couple. Okay. Yeah, this would be the simplest example that we have with Docker Compose. It's nice, it's simple, it works. Always bind mount your data directory and not right into the image, both for performance reasons or when you upgrade your image version, because otherwise you will just hate Docker for no reason because you're using it wrong. We used to have something to demo everything, and you can still get those configurations, but they're deprecated because we see not that much interested in Docker Compose anymore, to be honest. Nowadays, everything is, I guess, Kubernetes. Who is using Kubernetes? And then what always interests us is, like, who is using something else? Kubernetes seems to be the answer, and nobody's asking about the question anymore, but that's a different thing. Is anybody still using Swarm? That's a large number, okay. Nomad? No, okay. Mesosphere? No? Okay. Yeah, we saw that feature request every now and then, but we're still not sure we will ever provide any official resources for Swarm because everything seems to be going to Kubernetes. But you're a surprisingly large crowd for Swarm. Anyway, I guess everybody has or knows the Kubernetes diagram. That's not the fun thing. What you get lots with this is YAML normally. Who likes YAML? That's more a trick question, right? I always say this is like the Stockholm syndrome. At some point you get so used to writing YAML that you kind of like it, right? Since you all like writing YAML and you have lots of it, this is an example from the Docker documentation. Who knows what is going wrong here? Like you want to bind some ports, and something is going terribly wrong here. Who? Sorry? Yes, you need to. Yes, because what happens if you don't have the quotation marks? Yes. Why? Because it sucks. I'm not getting Yes. Yes. So what is going wrong here? If you run this through a YAML linter, you will end up at this. Because if you have this notation with colon, and that colon is lower than 60, it will assume this is the base. And then that's how you, this is, I think, calculated base 20, and this is how you get to this number. And this is how your port mapping is breaking in a very weird and unexpected way. So add lots of quotations. I think for the truthy and falsy values, the classic one is you have like a list of countries, and then you have DE and AT, and when you come to Norway, NO is obviously evaluated as false, which is one of the many ways that YAML can add fun to that. But we all like YAML, so that's where we're in. The one problem that we had with Kubernetes, but that was a long time ago, that it didn't allow dots in environment variables. And we configure everything through environment variables with dots. There was no good reason why you would not allow that, but it was just not possible until it was fixed. And now everything in general works with our images, for example. Who's using Helm, like the package manager-like approach? Clicker? No clicker? No. Yeah, it's like a package manager, allows templating, and you can just create resources as you go along. The nice thing about that is that it builds on the Kubernetes primitives that you have. So you don't invent new concepts or anything. All the concepts that you know in Kubernetes already, you can just simply reuse. For example, we have Helm charts for those, so they're still better, but you can just get the Helm charts and then set everything up the way you want, which works. The main question that people mostly ask about data stores is like, where do you keep your data, or how do you keep your data? Hopefully in a stateful set, because these allow rolling upgrades, and we will, for example, if you do a rolling upgrade and you have multiple nodes, we'll just bump one node, wait until it's joining the cluster again, and we will bump the next one, and stuff should be working as you expect it on. We do test currently on GKE, maybe because it used to be cheap. I'm not sure. We're still only testing on that now. The nice thing about the Helm charts that we have are that they are very unopinionated. So they really just tie into both the Docker, but also the Kubernetes concepts that you would expect somewhere else. So you just generate your certificates yourself, and then you bind mount them, or your key stores. The Helm charts don't do that for you. There are multiple upgrade strategies. So you can run our Helm charts in a similar way to probably many other Helm charts, and can use the approaches that you think that are best and suit your needs, which is very different to the operator, because the operator has a lot of operational best practices built in and does stuff in a specific way. But it forces you to follow that one way that we think is the right one. And if you think that is the wrong one, you're out of choices with an operator. With the Helm charts, it's more like you have the templating and you can just go wild on that. So in theory, to add that, you could just add a Helm repository, then you set up like, this is the version that I want to run. If you run it on Minikube, you would need to add some storage classes to run that locally. And then, yeah, we like make. We run that through make. So you can just do that there. And all you would need to do is something like define some limits of what you want to give it in terms of memory, CPU, and then the claim of the volume. We set, if you run it on Minikube, you will need to set a soft affinity that you can run multiple nodes on one Minikube cluster. That's basically all you need. And this will cut down on the YAML you need to write yourself kind of considerably. So just a small template, and then it will create a cluster for you and do upgrades for you as you go along. But everybody wants an operator. Who is using operators? Okay, a few. The nice thing about operators is that it's kind of expanding the way that Kubernetes does stuff. And the way you can think about that is now you can think in terms of services. Like in our case, you can think in like, this is an Elasticsearch or a Kibana service, rather than thinking about, okay, this is a Kubernetes service, and these are secrets, and these are stateful sets. You can basically abstract further away. And the way you do that is you have these so-called custom resource definitions, where you define kind of like the things that you have, and then we will bring those to life with a custom controller. That is basically a loop that runs continuously and that checks like your custom resource definition of what you want to have is what I have right now. If not, I will apply some changes. And it does a lot of stuff for you. For example, this one will generate certificates for you. It will set up security. It has a specific upgrade strategy built in. All of that operational best practice is part of the operator and will just run automatically for you. There used to be, for example, in our case, one from the community where somebody had written that, but he didn't have time to maintain and run that anymore, so we took that over, gave it this weird-looking logo. Also, for some weird reason, our product people didn't want to call it operator, but it's called Cloud on Kubernetes, so nobody finds the GitHub repository. And I will always, because the actual name that people have given it is ECK, like German corner, which stands for Elastic Cloud on Kubernetes, but nobody understands that, and I will always call it operator. So if you hear other weird abbreviations, we're talking about an operator, but we, for some reason, don't want to call it operator. Anyway, and this basically supports the server components that we have in our stack. It's built on Golang, KubeBuilder 2 for the SDK, and we're using Customize. If you're using a very old version of Kubernetes where we need to patch up some stuff and change some commands, we use Customize to actually have these different flavors or versions of Kubernetes supported. That's how we built those. And the general idea how this or any other operator works is, you, the operator, you install your controller and the Elastic operator here, and then you provide your custom resource definitions. These are the CRDs. This is basically what you want to your cluster to look like. And then that operator will, in a loop, continuously check what is defined here, what is actually running here. If the two are the same, I will skip and do another round later on. If there's a difference between what is configured here and what is actually running here, the controller here will try to move this state to whatever you have configured here. And this is another difference to the Helm charts. The Helm charts are like a package manager. Like you say, like install this version or install a 3-node cluster, and it will do that. And once it's done, it's done. And it will not run again automatically. You would need to manually run this. Whereas the operator runs continuously in the background. And it would always check like, oh, did a node die? You want 3 nodes, but you only have 2 nodes right now? Okay, I will create a new node for you. Which the Helm charts will not do, because the Helm charts are really just like a package manager. They run one operation for you. Do this upgrade, change the cluster to more nodes, but you run one command. Whereas the operator will always check like, okay, you want this? It's not there? Okay, I will try to move you to this state. And that's really the idea of what the operator is doing there. And unlike the Helm charts, this one is opinionated. So this encodes what we think is the right best practice for security, certificate generation, how an upgrade should look like. It knows, for example, if you scale down, let's say you have 5 nodes and you want to scale down to 3 nodes, it will not just remove 2 nodes, but it will drain the data from the 2 nodes. And only once those nodes are empty, it will actually remove them. So this is built in, and you don't need to configure that or run any manual commands. Or, for example, when we do an upgrade, we will make sure that the cluster doesn't freak out that, oh, a node is not there because you're upgrading it, and tries to reallocate data. It will just tell the cluster, okay, don't reallocate data right now because you're doing an upgrade, but you don't need to run that manually. That's all built into the controller and being done for you automatically. You can still shoot yourself in the foot though. So for example, if you have a single copy of your data, you do an upgrade, and the node with that piece of data is being upgraded, the data will not be available until that node comes back up. So it's not totally fail-safe or foolproof or whatever. Like, there is some stuff built in, but it's not 100% that nothing can go wrong anymore when you use the operator. Yeah, if you want to run that on Minikube, give it enough memory because this will take some more resources. And then what you can do is get the operator, then you can just check that it's coming up correctly, and then you can deploy your custom resource definition. And the next 3 slides are how the custom resource definition might look like. So rather than writing hundreds of lines of YAML, what you need to do is, for example, here, I can just say like, and you see here in the API version, you can see now you have basically an Elasticsearch, and this should not be beta anymore, this is a stable release. But here now you have an Elasticsearch service that you can use. And this is the name that we give it, so Elasticsearch sample. This is, for example, what the other 2 components will reference afterwards. And then I say, okay, I want this specific version and this node count and this memory limit and these data settings. And this will be the Elasticsearch sample name or service that you run. And then, for example, in Kibana or the APM server, you can see, okay, we have our own API version here again. This will just reference that Elasticsearch sample. And this is how you connect them. And you can just talk or think in Elastic services, and you don't need to really think in Kubernetes services anymore. The same thing then goes for Kibana. Since they don't really have much data, those are generally much simpler to configure. And once you have run that and you want to upgrade to the latest version, which is 7.6.1, you could just change the version in all of them, apply that, and then the operator would automatically figure out, okay, you have 7.5.2 deployed right now, but you want to run 7.6. I will move your cluster into that state for you. And we'll just do that in the background for you. Or if you want to scale something up and you increase the node count here, it would also pick that up automatically, like the reconciliation loop in the background would just pick that up and then add more nodes as needed or what you have configured. Yeah, you can check the status. For example, if you want to expose Kibana, you would need to set up the right port forwarding for that. And since we generate the secrets for you, you would need to extract them. And this is, for example, in our Elasticsearch sample user, under that JSON path, you could get the secret for the default user that we generate for you. You don't need to set it up, but you need to remember the commands to actually get to those details. So that's where you end up with those. If you change anything, just change it in the YAML file, apply that custom resource definition, and the reconciliation loop will pick it up and then bring your cluster into that state and you're done. That is pretty widely supported. We test that on all of those, and I think 1 or 2 other are on the roadmap. So the Pivotal Cloud Foundry, for example, we might add at some point. And again, it's using a stateful set, so you can do a rolling upgrade. And it's just kind of like the default best practice or standard way to do stuff right now. You have a stable network ID, a stable volume, and you can just reattach it when you upgrade. And you don't need to replicate lots of data around. Generally, where you want to store your data is in a persistent volume, either a local persistent volume or whatever your cloud provider gives you. So on Amazon, you might use an EBS drive or whatever to have that persistent volume to store your data. Sometimes when you don't really care about your data, you could use an mtdir or a host path. That is, however, not really recommended. It's more like, if you use your data more like a cache and you can use it or lose it and regenerate it at any point in time, this might make sense because it might be simpler to set up. But it's generally not guaranteed to be durable. And depending on, or you cannot enforce quotas and it could be evicted. So this is more for ephemeral data, which is, at least for us, not a super common use case. And you might be able to, or we might add custom storage interfaces in the future. We are not really sure if we really want to get down that rabbit hole yet. But the idea is, especially for on-premise installations and you don't have any mountable persistent volumes from your cloud provider and you want to have something similar locally, maybe we want to tie onto that, or maybe not. I think the team is still undecided for that. How do you deploy an operator, or where do you run an operator? There are generally two ways. So custom resource definitions will require cluster admin level permissions, and right now we're using privileged containers. So for example, the Elasticsearch container will apply this kernel setting on the host. And I said, mutating anything on the host is a bad practice. So probably we will get rid of that and you will have to set that up manually in the future. But right now we tried, or the operator tries to fix up the host with some settings for you. Which, yeah, we're not convinced this is the right approach, so probably you will have to set this manually in the future. But otherwise, on the permission level, there are two ways to run this. So you could have a dedicated namespace just for the operator, and that namespace would check all the other namespaces and check, are there any Elastic resources in them? And then it would just try to manage them. So this one operator here, and obviously this needs to have permissions on all the namespaces, could operate across all of them. So whatever team you have, each team, for example, has their own namespace, but your one operator manages all of those resources. The advantage is you only have a single operator running. The disadvantage is if you want to upgrade the version, this will apply to everybody. One thing that might be an advantage is that as long as people are working in their namespace, they cannot accidentally delete the operator or part of the operator. That might be an advantage. What the alternative to that would be is you could use a single namespace where you put the operator into one namespace and it will then only manage stuff within that one namespace. This has the downside that you will need to run multiple operators. Or maybe this is a feature for you. Depends a bit on how your teams like that. But this is the alternative. And then you don't need any global privileges in the Kubernetes cluster to install the operator in just your namespace. So permission-wise, this might be a bit nicer. You have a little more overhead because the operator is, since it's a Go binary, it's not super heavy. It, I think, should need like 200 or 300 megabytes of RAM normally. So it should just run somewhere on the side. But if you have lots of them, it might still add some overhead to your cluster. But those are the two possibilities to run that. If you want to look at other operators, there are a lot by now on Operator Hub. Ours is one of many, but yeah, the list is growing. Okay, to wrap up, and I think we have exactly 10 minutes left, which is kind of good timing. What we see every now and then that people are saying that containers are disrupting the industry, and I think most people see that positively, and we're always skeptical if disrupting actually means breaking production, because that's what we see quite often, because people use stuff wrong. Which then leads to the common question is, can I run Elasticsearch on Docker or Kubernetes? What is the answer to that? Yes, but what is the question that you should be asking? Should I be doing that? Should you? What is the answer to that? Yeah, we're the consultants. Yeah, if you're a consultant, you're very well trained in saying it depends, and normally it will cost a lot of money afterwards. You always need to kind of like discuss the trade-offs afterwards. But our point of view on that is pretty much like, well, you can, but if you should, is really up to you. If you run everything on Kubernetes and you have the experience and you think you know how to run data stores on Kubernetes, go wild. If you're just getting started on Docker and Kubernetes, maybe don't start with your stateful services, or at least not blame us afterwards if anything breaks. And then there's one thing that we see every now and then. I call this the Kubernetes paradoxon. When we meet the client or potential customer, and they ask us like, do you have an operator? And in the past we used to say, no, we don't have an operator. And they're like, oh, you don't have a Kubernetes strategy. Okay, this is a blocker. We cannot use your software. Goodbye. And then once you have an operator, and then you say like, yes, we have an operator. So you will start using the operator now. And then they will be like, no, actually we have like 2% of our workload on Kubernetes. But this is more like a long-term strategy. We want to see your commitment to Kubernetes. So this puts us in kind of this weird situation that if you don't have an operator, people will say this is a blocker, we don't want to use your software. If you have an operator, people will say like, well, this is nice, but we're not going to use it now. But I don't really see a solution for that, and maybe it will change over time. But this is kind of like a game that we saw multiple times. Like, we didn't have an operator, blocker, we had an operator, nice, we're not using it. But hopefully we'll get there in the future. When will you use a Helm chart, or when will you use an operator? The Helm charts are more, I would say, generic. I think and they are also, for example, internally for us, they're maintained by different teams. So Helm charts are done by our infrastructure team, and we used those initially heavily because we had those first, and there were also less work to create. The operators, since it's more code, is a much larger team. Like, I think the Helm charts are maintained by 2 people on the side. The operator has, I think, 5+ full-time people developing that for more than a year. The Helm charts are more like this unopinionated way. Like, it's like a package manager, it can roll out stuff, but it's more flexible and you can use it in one or many ways you want to use it. Whereas the operator is very opinionated. It will do stuff the way we think they should be, which might be nice if you don't have strong opinions on that. If you have different opinions, it might be an issue because you might not agree how we try to do stuff, and there is no easy way to work around that. And since it's all code, we have a lot of power and can just enforce things to do in a specific way. So if you want to have the slides, that's the QR code to get the slides. Questions, and I can let the next speaker switch over if you want to come on stage, but we can do questions now. Yes, shout. I mean, would I suggest to use it? So the operator is stable. It's officially supported by us. So obviously, we were saying, yes, this is the right thing and going forward. The question is more like, I think if you want to run Elasticsearch on Kubernetes, this will make your life easier and we take away a lot of the pain that you would face otherwise. The question is, should you run Elasticsearch or any data store on Kubernetes? So we use the operator internally quite a lot. So for example, we have a very large cluster for the information security internally, like what all of us are doing on our laptops and whatever. Like we have that, for example, running on the operator. So we use it a lot internally already, and it's working well. So the operator is probably the future and where we're pushing people. But again, if you're not on Kubernetes, don't just start with the operator because there's an operator. If you don't have Kubernetes experience, just doing an apt-get install will have like 1% of the complexity of the operator and probably will be easier to understand.
The last one is,
we have time, go on.
Else's operators?
Sorry?
On your infrastructure, use someone else's operators to have experience with that?
So internally, that's a very wide question because I'm not aware of any, but it's also hard to tell with all the teams that somewhere is some other operator. But generally, to be honest, we try to dog food as much as possible. So a lot of the stuff that we build is actually built on our own tooling. So no, I'm not aware that. So for example, if we provide internal services or like our own applications, those are often running as Helm charts just because easy to install and there's not much to do there. I'm not really sure if we use many other kind of like foreign operators. Other questions? Yeah?
Yeah, thanks for...
Wait, I think we have a microphone.
Thanks for the talk. I think it was super interesting. What I found a little bit intimidating was kind of like the 5 full-time engineers working on the operator for a year. I think that sounds like a lot of effort. So my question would be, are there any frameworks that would help you leverage or enable some sharing between Helm charts and operators? Like, for example, convert the CRD into inputs for Helm and then have it be applied, and maybe with the option of adding custom logic for upgrades. But it's, as you said, like they're kind of like serve a similar purpose. Like one is dynamic, the other is static. So it seems like a lot of this reconciliation, like if you have your YAML definitions of what you want your state to look like, and the Helm charts give you that, it seems like there's quite a bit of like automation you could employ to generate operators out of Helm charts.
Maybe. At least we have gone the other way, because the Helm charts are easier and quicker to write. So people will mostly start with that, and then if you want kind of like a richer feature set, only then I would move to the operator. But coming from an operator generating Helm charts, sounds like...
So no, I meant it the other way around. Like you have your Helm charts, and
sorry,
you basically have a generic operator that you like instrument with some logic to convert CRD data to a Helm chart, and that applies like basically employs reconciliation to like always keep the class or always keep the case objects in the state prescribed by the Helm chart.
Maybe some, but at least in our case, definitely not everything, because like the operator does a lot more work, like around certificates, key stores, backups. All of that is kind of built in, and it's just code. Since it's just Go code, you can go wild and do lots of stuff, and that's why you have way more people in there. And the other thing is, maybe 5 people sounds very intimidating, but this is not just like the operator side, this is also a lot on the best practices of the Elasticsearch side itself. Because then you need to know, like, how do I move from this version to that other version? Like, what can go wrong, or what migrations do I need to run? Mm-hmm. So there is a lot of these operational best practices built in, and maybe you shouldn't see it as a scare factor, but more like a goodie for you that 5 people have basically been working out, hopefully, these upgrade paths, for example, for you, and you don't need to care about them anymore.
Oh yeah, I mean, like from a perspective of an Elasticsearch user, definitely. From a perspective of a company that wants to offer their product via an operator, that is what I meant by intimidating.
So I think from where I've seen it, where people didn't have that many resources, normally I would see Helm charts come out. Operators are generally more work, but obviously you can do them in kind of like different levels of complexity and feature richness and everything.
Thank you.
I think we have 1 minute left. Final question?
Yes.
Okay.
I can also show. It's okay. So just quickly to the operator stuff. There is actually an operator framework. It's called Kudo, which is basically a Kubernetes Universal Declarative Operator framework. It's pretty new, but what they are trying to do is basically what you're describing for stateful applications, to have just an operator framework where you, in our favorite language, YAML, can define an entire operator. Questionable if that's going to be in the future relevant or good, but they are also taking that approach. So maybe that's for you to look at and goes in that direction.
Thank you.
Yeah.
Cool. If you want to grab stickers, I'll leave the stickers here. If you have other questions...
we have one question.
Sorry.
Sorry.
Okay, but it's longer, so...
No,
Yeah, just find me afterwards. I'm here today and tomorrow. If you have any questions, just find me. I'm happy to answer.
I have full of tricks of you have looked in your GitHub repository and let us talk.
Right. Thanks a lot.